Okay, so we want to start making our board. So for this, I'm going to first of all go to my hierarchy and I'm going to right click and I'm going to create a board object. And then I'm going to go back to my assets. I'm going to create a scripts folder. So create a folder that we'll call scripts. And then in here, I'm going to create a C# script that we're going to call board. And this is going to control our board. So then I'm going to, once that finishes compiling, there we go. I'm going to click, make sure I have my board selected here, and then click and drag this over there. So now we have it all set up first, and then we're going to start writing some code that will allow us to actually generate the board itself. So let's go into board here, and this will take a few moments to open Visual Studio. And once that's opened up here, the first thing we're going to do is create a couple of variables for us to use. We want to know how wide our board should be and how high it should be, because we want to be able to set this up for lots of different levels in our game and have different sizes and things like that. So I'm going to create a public int value called width, and then a public int value called height, like so. So I have my width and my height, and then I'm going to create a reference to the tile, the background tile that we created a little while ago. So I'm going to create a public game object that we're going to call bg tile prefab. So for now, I'm just going to save this and let's go back into Unity and we'll set those few little things up. So we'll let this compile. For our purposes, I'm going to set this width and height to be 7 by 7. You can obviously set this to be anything you want. I'd recommend not going too small and not going too big. Like, don't go anything above maybe 15 at the most. Because while it will work, and I had some fun testing out things with like 50 by 50 boards and stuff, it will make things go very, very slowly and make things a little bit harder for you to work on in general. But we'll just stick with 7 by 7 for now. Then our tile prefab, let's go to our prefabs folder and I'm going to grab the tile background and I'm going to pop that down there like so. And then let's go back into our scripts now. And basically what we want to do is when the game starts, we want to make our board set itself up. So with that in mind, I'm going to go just below, actually I'm going to get rid of update because we're not going to use update at all. Instead, what we're going to do is create a custom function called private void update. Oops, a whole bunch of things auto-completed there that I didn't mean to. There we go. So we have our, wait, why did I say update? Have update on my brain. Private void setup, that's what we want, just because I deleted the update, it was in my head. What we're going to do is when our game first starts, we're going to use the start function to call this setup. So in here, I'm going to say, as soon as the game starts, do our setup. And then in setup here, what we're going to do is we want to use two what are called for loops. Again, if you haven't encountered for loops in your coding career so far, for loops are a very, very handy thing that you can keep repeating the same action over and over again, but for a different given value. So what we're going to do is start at an x value of 0 and go to the width of our board, and then a y value of 0 and go to the height of the board. So that will fill in every position on our board as we go. So let's just write it and we'll understand how it works. So we're going to say for, like so. So for loop has our open and close brackets and then our open and close curly brackets. But within this open and close brackets, we require three things. We have to have a value that we set up. So we're going to have here an int value that we're going to call x, and we're going to set that to be 0. Then we're going to have another value that checks if something is true. So we're checking if x is less than the width of our width value. And then finally we'll say x plus plus. So again, if you haven't seen this before, we start off with an x value of 0. We're going to do a check and see, hey, is x less than the width? So our width is 7. So it'll say, is 0 less than 7? Yes, it is. If that's the case, then it'll go in here and it'll do whatever code we put inside this bracket. And then it'll go, at the end, it'll go back to the top and say, add 1 to x. So x plus plus is the same as saying x add 1. So x plus 1, you could say. You could say x plus equals 1 or anything like that, but it's a shortcut way of just saying, hey, just add 1 to our x value. So then x becomes 1. Is that less than the width? Yes, it is. So keep doing that. Then it's 2, then it's 3, 4, 5, 6. And then when it becomes 7, it says, oh, is 7 less than the width? Well, no, it's not. It's the same. So then don't do any of the code in here, and then just continue on with whatever we put down below here. Okay, so that's our x value. We're checking if it's less than the width. As I said, though, we also want to check the y value. So now we're going to say here, for int y equals 0, as long as y, not u, as long as y is less than the height y plus plus. So now when we get to this point here, on the first loop through, so our x will be 0, and then it'll come down to here and say, okay, and also have a y of 0. So now we have an x and a y value of 0. Then next it'll do this little bit, then it'll add 1 to the y. So then it'll be x0, y1, and then x0, y2, x0, y3. So what you'll have is, if I just quickly open a little paint here, let's just make a very simple grid like so. So it'll start off at x0, x0, y0, then it'll be x01, x0, y2, 0, 3. Then it'll get to the height and it'll say, oh, that's high enough. So now go to 1, 0, 1, 1, 1, 2, 1, 3, and then 2, 0, and so on, blah, 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 until we get to our 3, 3 up here. So it's just important to know that the way this for loop is going to work is it's going to fill it from the bottom left, which would be 0, 0. Then it'll add up the ones all above it, then move on to the next column and move them, fill them in, up, 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 and then over to the next column, and then up, 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 up. And this will be all happening so fast we won't be able to tell. It's just important to be able to understand that logically, because we're going to use this same system a good few times throughout this course. So with that done then, we're going to create a new value that will store the x and y's here. So we're going to create a vector2 called pos for position, which is equal to a new vector2 that has x and y as its values. So now we have our 0, 0, 0, 1, 0, 2, and so on. And then in here we're going to say, we're going to create a game object that we're going to call, we're just going to call it bgtile, and that's going to be equal to instantiate, so create a copy of our bgtile prefab, so bgtile prefab. We want to tell it where we want it to go. Well, that's wherever our position is here, so position. And then we have to tell it what rotation to have. We don't want it to have any rotation, so we can just say quaternion.identity. So that's basically a shortcut way of saying have 0 rotation on our object. Okay, so that will pull in our background tile here, and I'll just save for the moment and we'll see how that looks. And there's one extra thing we want to add into this just to make it a bit tidier. But for the moment, let's just let this play out. Okay, and if I go ahead and play now, we should see, once it spawns, there we go, we have our objects all spawning in correctly. I'm going to turn off this maximize on play so we can just see it down here, and we can see our prefabs down here. So it started at position 0, which is where the center of our board is, and then it goes to 0, 1, 0, 2, 0, 3, and adds them all in one by one and adds each row as it goes. Now, one thing to note is that we put this in and now it's filling up our hierarchy here with all these tile background objects here, which isn't great for when you want to find something that's happening in your game if your whole hierarchy is filled up with all these copies of things you've made. So one thing we want to do is back in here, and this is the reason why we set this to be equal to a new game object here, is that right below that we're going to say our bgtile dot transform dot parent is equal to transform. So it's equal to the transform of the board object. So now let's save that and we'll go back in here. And again, once this compiles, we can press play. And they all get brought in, and now they don't fill up our hierarchy. Instead, they get put underneath the board here. So we can still find them all whenever we want to, but they're no longer clogging up our whole hierarchy. One thing I'm going to do as well is, because I'm already noticing that it takes a few seconds to start the game when I press play, I don't want that to happen. So I want to go to my edit here and go to project settings. And if I go to editor, and if you scroll down near the bottom here, there's enter play mode settings. I'm going to set that to true. And what that means is it'll turn off reloading domain and reloading scene. So basically it won't try and reload everything to actually play the game. That's normally what happens in Unity, is when you press play, it reloads everything and then starts playing the game to make sure everything's at its initial value. But we don't want to do that. We want to keep it nice and simple because we don't have any crazy things going on that we need to keep track of. So now when I press play, it'll instantly start up the game for me. It's a handy little trick to save a lot of time. It really adds up all those little seconds of waiting for your game to start. One final thing I want to do with setting up our board here is when we create the background tile here and set its parent, we're also going to change the name of it. So I'm going to say our bgtile.name is equal to, and in quotation marks we're going to say bgtile dash and a space, and then we'll close that quotation mark and we're going to say plus x plus, and again quotation marks like this with a little comma in the middle, plus y. So what this is basically say, the pluses, when we have what's called a string here, if I hover over it you can see it says it's a string. So a string is just a collection of letters or numbers, whatever. So bgtile and all this little bit of writing, and then when we add on the x value, which will be 0 to 7, it'll say, okay, bgtile space, it's say 3, 4. So it's just a quick way of doing that. So now if I save this and go back in, now we'll just be able to see that the tiles are being laid out in the correct way. So we've got our bgtile 0, 0, they're all being given the correct numbers. And hopefully you might notice that we're going from 0, but we're only going up to 6. So we said our width and height is 7, but we're only going up to 6. So if you don't understand what's going on here, just as a quick explanation, you can see we do have these 7 values, but the way things work in general in coding and specifically in Unity is that the first value will generally always be referred to as 0. So this first tile that we have here is 0, 0. So then we have 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, and 0, 6. Or sorry, that's the wrong way. But 0 up to 0, 6 up here is the 7th one. And that's really important to be aware of, that the first value will be 0 and then the 7th value will be 6, because when we get into moving things around with arrays and things like that later, it'll be really important that we know, hey, these are all the objects that we have, and this is how we can access a specific one, because we know the exact number to access any of them. So we know, for example, that if I want to specifically access this block here, now I know it's at position 4, 3. So it's just a handy way to visualize that stuff. Now, one other thing to note, of course, is that, well, right now we can't see half of this, well, not half of it, we can't see a chunk of this board off the screen here. So we want to move our camera. So depending on the size of board you use for any particular level, you'll want to move your camera around. Now, you could do this through code to make the camera automatically work stuff out, but it's actually much quicker and much easier to just do it. So we've got our camera here. One handy thing to note is that, hey, the camera's position should basically be half of the width of our board. So if I say 3.5 here, that's not quite in the middle, it's actually a little bit over. You'll see that the camera is, rather than being in the middle of this tile, it's 1 over. So basically the camera's position should be half of the width or the height of the board minus 0.5. So now I'm going to have this be 3. And if you don't want to have to work that out every time, you can actually type in formulas when you're entering in numbers into Unity here. So I can say 7 divided by 2, and then I can say 3.5 minus 0.5. So that gives me the 3, and now my camera is right in the middle. It's in the position I would want it to be. So now I can see that will work. So let's stop this running and make sure when I stop the game, because when you stop the game, all the values go back to what they initially were. We need to make sure we set the camera again to be 3, 3, like so. Okay, so let's save this then. I'm actually going to make sure I save this as a new scene. So I'm going to go to, I can hit Control Shift and S, or I can go to File up here and Save As. And I'm going to go to my Scenes folder, and I'm going to call this the test level. It's important to remember to save your scenes as you go and give them sensible names as well. So we've got our board now generating correctly, and you can see if I do actually change the values of this, it will generate the board in different sizes. So if I wanted to do a 50 by 50 board, it will just spawn that whole big massive thing in for us. But we don't want that, we want to keep it nice and simple, so let's just leave it at 7 by 7, and now we'll move on to bringing some gems into our game.